Hello everyone, let's discuss about circuit sensitivity of strain gauge. In previous lecture we discussed about the sensitivity of potentiometer, and in this lecture we are going to discuss about the sensitivity of Wheatstone bridge circuit in the strain gauge. Alright, so this is what a Wheatstone bridge is. Let's revise it quickly. So there are four resistances: supply voltage and output voltage. Alright, the output voltage E would be given by V into R1 R3 minus R2 R4 upon R1 plus R2 multiplied by R3 plus R4. Alright, so initially R3 is equals to for balanced circuit, that is E equals to 0, the value of R1 multiplied by R3 will be equals to R2 multiplied by R4. Alright, so this is the case of balanced circuit, right? So the change in output voltage can be measured by this formula, that is V R1 R2 upon R1 plus R2 square multiplied by delta R1 upon R1, that is change in individual resistance, divided by the original value of resistance. Alright, now we take the ratio of resistances R2 by R1 is equals to R, and this equation can be rewritten in this form. Alright, now for Wheatstone bridge sensitivity, it is defined as the ratio of change in output voltage and strain. It is ratio of change in output voltage to strain. This is the sensitivity. Alright, so it will be equals to VR upon epsilon into 1 plus R square multiplied by delta R1 by R1 minus delta R2 by R2 plus delta R3 by R3 minus delta R4 by R4. Okay, and this will be equals to VR upon 1 plus R square 1 plus R whole square multiplied by N into SG. Alright, the number of gauges used is N, and their relative position in the bridge are important and are shown in the following cases. So the first case is, let's first see the diagram. There is a Wheatstone bridge and there is one active resistance. Okay, and that active resistance is kept at the place of first resistance at the position of R1. Alright, and this is the circuit. Alright, so in this first case, and there is a temperature compensation in the circuit, it is not critical. Alright, and R1 is equals to RG, and this ratio is maintained. Alright, for initial condition. Fine. So in this case, the output voltage will be V is equals to IG multiplied by R1 plus R2, and it will be ultimately equals to 1 plus R and under root of PG multiplied by RG. This is very similar to the condition that we saw in the potentiometer circuit, right? Sensitivity of potentiometer circuit. Okay, so from this equation 4 and this equation 5, we can come to the sensitivity of the first case, that is R into R upon 1 plus R multiplied by SG into PG upon RG, PG multiplied by RG to the power 0.5, that is under root of this. So this is a separate factor and this is a separate factor. As the value of R increases, this tends to unity, that is it becomes 1. So we get maximum circuit efficiency, and this depends on the selection of the gauge. Alright, so this was the first case. Let's go to the second case. So in second case, the bridge arrangement is something like this. In the place of R1, there is an active resistance, and in place of R2, there is a dummy resistance. Alright, and this value of R1 R2 is equals to RG, and the value of gauge current passing through both the gauges is given by this equation. So using this equation and this this sensitivity equation, we can determine the final equation for case 2 as SE is equals to 0.5 multiplied by this factor. Now compared to previous case, their sensitivity had a range, circuit effectiveness had a range from 0.5 to 1. In this, this parameter is a constant. Alright, so next come to the third case. In third case, the change is, there is an active resistance in position of R1 and there is a dummy resistance in position of R4. Alright, and R2 and R3 are the fixed resistors. Alright, and in this case the position temperature induced changes are cancelled out. So the current through both the active and dummy gauge is given by this equation, and again by combining the equation number 4 and 7 with n equals to 1, we get strain sensitivity as R upon 1 plus R Sg multiplied by under root of Pg into Rg. This is very similar to case 1. Alright. Now let's come to fourth case. In this the circuit arrangement is something like this. There are all the circuits are active, all the resistances are active resistances, and so the position n equals to, in this position n becomes 4, and the power dissipated by each of the 4 gauges is given by this equation. Since R1 and R2 are equal, so it becomes 2 times Ig into Rg. Alright, and V is equals to 2 times under root of Pg into Rg. Okay, since resistance is same for all the gauges, so the resistance ratio becomes equals to 1, and therefore the sensitivity is 2 times Sg multiplied by under root of Pg into Rg. Okay, so this 4 active arm bridge is more sensitive as compared to the bridge in first and third case. Alright, and also this arrangement is temperature compensated. Okay, thank you.